Hello, and today's learning target is I can use the converse of the Pythagorean theorem. I can know a few Pythagorean triples. So here, today we are going to look at the converse, which means the opposite of the Pythagorean theorem, because before we've already done some exploring and research into the Pythagorean theorem. So again, converse means opposite. So if we look at the definition, converse, and again, converse here means opposite. Let's fix that. That should be an O. That's going to bug me there. Okay, so opposite. Converse of the Pythagorean theorem. If any three positive numbers are a solution to the Pythagorean theorem, then they make a right triangle. So again, this is opposite of the Pythagorean theorem. So if any three positive numbers are a solution to the Pythagorean theorem, and I'll abbreviate theorem THM, then they make a right triangle. So now let's look at a few examples and use the converse of the Pythagorean theorem to check if the following side lengths make a right triangle. Let's look at the first example. So again, we are going to use these three side lengths of 30, 40, and 50, and I'll always plug the two smaller sides in for the two legs, A or B, and the longest side always needs to be C. Now it doesn't matter which value, 30 or 40, go in for A or B. Those really can be interchangeable, but those both need to be either A or B. And 50 here needs to be the longest side, which is always C, so that one does have to be correct. So here if I plug these into A squared plus B squared equals C squared, I will plug in 30 squared plus 40 squared, and does that equal 50 squared? Now, I'll put a question mark in here because we got to figure that out, right? We don't know exactly if it does equal, therefore making a right triangle. So if we go ahead and solve, 900 plus 40 squared is 1600. Does that equal 2500? Well, 9 plus 16 is 25, and then add on two zeros, so 2500 does in fact equal 2500, so these three sides will make a right triangle. So for our answer here, we could say 30, 40, and 50 make a right triangle. Whoops. Okay, let's look at the second example. So let's start out with A squared plus B squared equals C squared. And that would be 6 squared plus 12 squared equals 18 squared. And again, we can put a question mark here. And 6 squared is 36. 12 squared is 144. And does that equal 18 squared is 324? So 36 plus 44 is 180. Does that equal 324 with a question mark? Well, no, it doesn't, so I'm going to put a line through the equal sign, which means does not equal. So this would not be a right triangle. So not a right triangle. And again, A squared plus B squared here does not equal C squared. 6 squared plus 12 squared does not equal 18 squared. Okay, let's take a look at the third example, 4, 5, and 6. So again, I'm going to plug them into A squared plus B squared and see if it equals C squared. So 4 squared plus 5 squared, does that equal 6 squared? I'll put a little question mark. 16 plus 25, does that equal 36? Well, no, because 16 plus 25 is 41. 41 does not equal 36. So this is not a right triangle. Okay, let's look at one more example here. So again, we'll see if A squared plus B squared equals C squared. So 9 squared plus 10 squared, does that equal 14 squared? Put a question mark in the middle there. And 9 squared is 81. 10 squared is 100. Does that equal 14 squared, which is 196? Well, we know 100 plus 81 is 181. And so does that equal 196? No, it doesn't, right? So I'll put a line through it, so this will be not a right triangle. So only one of these examples here actually was a right triangle, and definitely need to use the Pythagorean theorem to check if these three sides will fit into the Pythagorean theorem, and then therefore will they be a right triangle, yes or no. Okay, let's look at the next few examples. Now let's take a look perhaps at a word problem. We are still going to use the converse of the Pythagorean theorem, but now it's just in a word problem. So let's take a look at what it says. Alex wants to plant flowers in a triangular plot. She has 3 lengths of plastic edging, and the measures of them are 8 feet, 15 feet, and 17 feet. Determine whether she will be able to create a right triangle. So again, this is going to take using the Pythagorean theorem, and I'll go ahead and zoom in here, of a squared plus b squared equals c squared. And so here we'll use 8 squared plus 15 squared, and again the longest side is always c. So does that equal 17 squared? So I'll put a little question mark there. 8 squared is 64, 15 squared is 225, 17 squared is 289. So 64 plus 225 is 289, and 289 equals 289. So yes, she will be able to create a right triangle. Now the next few examples we're going to look at are going to be called Pythagorean triples. However, what we just solved here with this word problem and figured out 8, 15, and 17 worked out in the Pythagorean theorem, that actually is called a Pythagorean triple. Now you do not have to memorize these. The more we practice these, the more you'll recognize and remember which ones were Pythagorean triples. But it's good to start understanding what that means, that the 3 numbers can fit in the Pythagorean theorem. And again, just the vocabulary word is called a Pythagorean triple. So let's take a look at a few more examples. So the definition of a Pythagorean triple is a set of 3 integers that works in the Pythagorean theorem. So the four most basic sets of Pythagorean triples are 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. And we just looked at a word problem with 8, 15, 17 in it. Those are the 4 most basic, but really there's an infinite amount of Pythagorean triples because we can, use whichever numbers, small or large, to create this. And another cool fact is that multiplying all 3 numbers in the Pythagorean theorem, or of Pythagorean triples, by the same number can also scale up a triple. So for example, if we take 3, 4, 5 and multiply it by 2 right here and get 6, 8, and 10, that also is a Pythagorean triple. Or if we multiply it by 3, get 9, 12, 15, that's also a Pythagorean triple. So really, there are endless amounts of Pythagorean triples, but it's good to start recognizing these right away, but you do not have to memorize them. So just another fun fact about Pythagorean triples. Thanks for listening to the video. Have a great day. Bye-bye.